So the last time we actually have covered the basics of like the basics of C# syntax and playing with the console applications and covering certain things. And also we have covered how to use math class libraries and such. So I'm actually going to erase all of this, and let's actually talk about the new old topics, which Dennis has covered. Okay, just making sure the my insert didn't activate by mistake. And I will erase this as well. And actually, I will leave math tools because, I mean, it doesn't hurt us anyway. And when we will actually make the rest of the new task, which I've given to the students today, we will create just another class library. Now, classes, inheritances, function overrides, and abstract classes. Let's cover the syntax and the reasoning, why we use each one of those and when. Can somebody tell me, or if you don't want to say it in audio, feel free to write it in chat. Can somebody tell me what is the difference between an abstract class and a class? I know that you already have passed that through C++, but can you please tell me the difference between them? Some brave soul, just please write on the chat. You don't need to speak in audio if you are shy. We can't create objects of abstract classes, okay. Do you know, not you specifically, but do you know, does anybody know when to use abstract classes? Why would you use it? Why would you choose to use it? So let me give you a quick example here. Let's actually talk about this because this is actually super important. Let's say that you have a public class person or also, and then you have a public class student, right? And right here you can have a public string name. Everybody has a string, everybody has a name and an age, right? Now you can actually make a student inherit from Osoba, yeah? And then you can have a professor inherit from Osoba as well, right? However, each one of them has a different functionalities. For example, this has a int index, as you always guys have, and this guy has, for example, title. What is exactly his title, for example, right? The academic title, let's call it that way. For example, academic title can be another type, or it should be another type, but we will not discuss the software design here. We are just doing the basic stuff, right? Why do I actually, for example, say, why shouldn't I say, for example, here abstract? Or why should I say here abstract? I mean, yeah, obviously you will not create a new object of Osoba, but there has to be a reason, another reason why you would use abstract classes, right? Now, the reasoning behind this is that the cool thing actually about abstract classes is that you can create half of the implementation and hand over the rest of the implementation to programmer B. So if you are programmer A who's programming this, and for example, programming this part, let's say you are tasked with creating a class, a person class, and you have to make sure that this person has all the necessary properties for to make this person class functioning. So everybody else who's programmer B or other programmers in your team, they'll create a student class and then they will inherit from your class and so on and so forth, right? So what do I mean by making half implementation and then leave the other half to the people to do it? Let's say that you are 100% sure that every person in the world is able to live or has to be able to breathe, right? So you can have a public void breathe, right? And here you can say console.writeLine, I am breathing. My name is, let me actually put here the thingy, and my name is this.name, and I'm breathing, right? However, everybody, every one of us, as a person, every one of us is actually able to teleport. I mean, obviously, everybody thinks of teleporting like the instantaneous teleporting, but no, you are actually literally moving from one place to another using a car, or using a train, or using an airplane, or by foot. So, so it's really up to you how you would like to teleport a person. And hopefully in the future, you will just beam people up or down or anywhere else like in Star Trek universe. So right there, how person is being teleported is up to the implementer, right? So here you have the implementation for breathing. So here you write the logic for breathing, expand lungs or make the heart working, blah, blah, blah. Just the main thing that this has to function. And this is common between all of them. However, what is not common is how the teleportation is happening. So you say public abstract void teleport. And right now, you see I got an error here and here saying that every class which inherits from Osoba has to define what their teleportation is because we have no clue how the teleportation would work, right? So right here, the student has to define how the teleportation will work. So I can, for example, say Alt-Enter on the student and say implement abstract class. And right here, I can say, okay, console.writeLine. And then you say teleporting by foot. So the guy just simply walks. A professor is a little bit of a fatsa, as you guys say here. So we're going to say he's actually teleporting by car. So this guy just drives a car. Now here's the cool part about this. If you would like everybody to teleport right now, so we're going to create an array of this guy, right? So you can say var osobe equals to new osobe array, right? And right here, I can add new stuff. Using polymorphism, I can say new student, and then I can have right now the name equals to this. Age, we already have set this to 100. And index will be, this is what index was, integer, right? So let it be 1, 2, 3, 4, 4, 5, 6, right? And right now I'm going to have a new professor because again, polymorphism. He also has a name, which is going to be Mohammed. He also has an age, which happens to be -1. And he has an academic title, which is going to be something. Okay. So right now I have an array of people here. Now what I can do is say, please make each one of them breathe and make each one of them teleport. So right now I can say for loop, and I say also bed.length. And here I would say that also bed of I dot breathe, and then also bed of I dot teleport. Now each one of them will call upon the overridden function, or method rather, and call for everyone who has their own implementation of teleporting. And right now, you as a programmer, you have empowered your other fellow programmer in order to expand on the implementation of their classes by providing their own, thing. So right now, you actually gave half of the solution, which you know that it should work and it will work. And then you give the other people to finish the other half of the solution, right? This is when you're going to use abstract classes. Half of the solution you provide, the other people has to provide the other solutions to make the solution complete. So if I go ahead and Control F5 this, you see here, my name is Dennis and I'm breathing, teleporting by foot. My name is Mohammed and I'm breathing, teleporting by car. You see? So this is actually, this is one of the things why you would use actually an abstract class. It's actually different from interfaces, which we're gonna come to it somewhere next, probably next class or the class after. Okay. Does this make any sense? Let's see. So basically, you can make an abstract for creating common interface or other classes such as students and professors. So we can use abstract for creating common interface. Yeah. You can say so. Yeah. You can say so, but I will not say interface because interface is actually a software engineering concept or a construct. So because it will confuse you later. So I would actually say that use abstract classes for creating, a common class, I would say, not a common interface, but common class for other classes, such as a student and a professor, where you have half of the implementation is already done, and the rest of the half or the 3/4 or whatever, the rest of the implementation is done by the second program. Does this make any sense for everybody? Okay. All right. So this is like I have covered right now like couple of things here. So I have actually covered inheritance, function overrides, and abstract classes all in one example. Let's talk about the null checks. So there are actually two ways of null checks in C#. One of them is actually 2 or 3 ways. Oh, okay, fine. Let it be actually two. Well, actually, it starts with like 3 ways, I think, or even more. So, for example, let's say that you create a professor. So you say professor prof equals to null. Okay. So you can check for this guy like so. Prof if prof equals null. Then you say console.write line, for instance. Prof is null. You have another one. You could say, which we use in game dev a lot, is reference equals. And then we say prof and null. You will not see this in production. Like if you are doing full stack, I don't think I have seen this before in full stack. But it exists. I mean, I'm using it as a game dev. There is another one, which, for example, let's say you would like to know that if it is not null, then please just, do something. And there is the null coalescing operator. And the problem is right now here, I need to probably install a newer .NET framework, because you could do this, profa equals to new professor. I think this is the part where, yeah, the feature of null coalescing assignment is not available in C# 7.3. Please use language version 8.0 later. Let me see if I can enable this right now. Enable. Let's see. I'm actually going to try just to see if I can. I mean, I think. Okay. So I can probably close this and reopen it again. Maybe it will work. Ah, now it works. Okay. So, oh, now it doesn't. Apparently still, I'm missing something definitely, just I don't know what now. Assembly information, nothing in here, builds. Yeah, I just need to figure out. Yeah, probably I need to download and install the new .NET SDK maybe. Let me see, actually, let me actually try this. Somewhere here, I can see if I can nullable enable. Probably it will ask me to, yeah. I need probably to download the new version of it. But in any case, this is one way of, like, you need to install just the latest C# SDK, which I haven't for some reason or another. I will probably off the screen, I will actually install that later. But in any case, like if you have something that is null, you can actually generate a new object out of it. If it is actually null, then sorry, if it is null, it will generate a professor. If it is not null, it will just simply ignore the line and it will just kind of carry on. So you have these null checks, which you can actually play with. Also, you have something along the lines of this. So profa dot, and then, for example, if it is not null, you can say name. You're going to actually modify the name, for example, from Mohammed to Dennis, for example, right? Don't tell me that I need to. Left-hand side. Did I get the syntax wrong all of a sudden? What did I get wrong? Ah, sorry. Right. Actually, I got this wrong. I mixed it up with delegates. So var current profa name equals to this. So if you got, for example, if you would like to get the professor's name and he probably might be null, you put the question mark dot name. So if this actually null, it will just simply silently fail it and it will just simply ignore it. If it is not null, it will just simply grab it. So practically speaking, this unpacks to something like this, which is going to be along the lines of, or actually, hang on. It will actually, so this guy will unpack to something like if profa doesn't equal to null, then you will just simply say current profa.name equal to profa.name. And it will be like this. So this unpacks. So this unpacks to this. Okay. So we know about the null coalescing operator and the null coalescing operator like with an assignment, but you need like the additional .NET framework, the new SDK. Let's actually talk about out. So out is an interesting problem. If you have a function that needs to return two things at the same time, you can use an out. Some people might argue this is also a bad idea, but it really depends on where you are using it. So for example, we could use out in terms of instead of returning a specific type, if you would like to go high on performance, let's say. But if the performance is not an issue for you, you might actually return a type instead. So let me actually explain to you what I'm talking about here. Let's say, for example, in games, and it's actually like, it literally would look like this. In games, we have something which is called array cast. And array cast is, in game dev, array cast is like, imagine that you are a blind man walking with a stick and you are poking things around you. And if your stick hits something, you would like to know what the thing you hit and at which position, right? So you would like to know whether you hit something, so it's a Boolean, and the position, where did I hit the thing? This is literally what array cast is, just a blind man with a stick, just trying to poke things around and see if I actually hit something or not. So at the end of the day, you will end up with something like private static, because I need to call it from main here, bool raycast, and then one of the stuff besides the raycasting, like where you are trying to poke the stick and stuff like that, it will actually give you out, for example, where, or for example, what did I hit? So it's going to be, let's say, a vector3 in the math tools is going to be like, so a vector3 is like X, Y, and Z. And it says like, for example, position of hit or hit position. Let's say so, and it should be like so, H. And here's the interesting part. You have to return, of course, like you have to do your checks, where did I actually hit and stuff like that, but at the end of the day, you can return true. And obviously, you need to actually assign this thing. So hit position equals to new vector3. And right now you say, I hit at this and this and that position. So right now, your function actually has returned two things, right? It returns the Boolean, whether I hit something or not, and it also returns the hit position. Now, obviously, this out has to be the last parameter in the parameters list of a function or a method. So, for example, if I have here, for example, like vector3 direction of hitting, or direction of poking rather, right? Because you are poking with a stick. So direction of poking, for example, this has to be at the end. It cannot be at the beginning. So if you actually try to do this, I think it should actually scream at us right now. See? Oh, actually didn't. Did they update this? Probably they did. Probably they did. I can remember clearly it didn't allow me to do this in the past. Maybe something new with C#. I will have to check this out. But in any case, let's put it here at the end. So some people might argue that this is a bad idea, and some people would say, give me a type, a new type, or a new return type, which is going to be, for example, a public class array fast hit info, or simply hit info, which says, for example, public bool has hit something, right? You also have public vector3 hit position, right? And then some people might say, aha, okay, I will actually just simply said, return just the hit info and do not do this anymore. And right here, you just simply say return hit info. Sorry, let me new hit info. And right here, you can say has hit something equal to false or true, and hit position equals to new vector 3, right? And right here, before that, you put your all your logic for a casting goes here. Okay. So that's the two arguments. Some people might say, please do this, and you will see this a lot in production, especially in full stack dev. And you will see people who are trying to go around certain problems by using the out parameter without the need to define a new type, like so. Okay, so I'm giving you the two sides of the story here, and you can actually pick. Okay, so these are the two highlights which I wanted to actually mention. I wanted actually to dig deep or tackle it a little bit more deeper, so you can actually think about them when you're writing your own software. And probably it will be reiterated even more when you're actually getting to when you get to work with with the other subjects like Eresiad and Eresdva. Okay, so here's the next question. Now that we know all this syntax and all that stuff, let's actually design a system, design something that you can actually use. So in the class, and right now I need your interaction, to be honest. So please write in the chat your responses. In the class, I've actually said, okay, it is super important, and I also mentioned this in the class. There is an interesting talk in a game developer conference about a guy who actually made like 50 list of 50 things. The title of the conference talk was if you are listening to this, you should be fired, or something like that. I think it's called that way, and it's actually kind of fun because the guy was actually talking about the minimum requirements of any software engineer who's actually have to be working with him. And he says this has to be known by these software engineers. If you don't know this, then you should be fired, at least from his perspective. I mean, I will not be firing people, but at least you really need to know some of these things. And one of these things are, and actually everything is applicable in that list which he said. All of it is actually applicable to any software field, like anywhere almost. So what he said was, you need to, it says like this, one of the points, I clearly understand the problem. And then later on, one of the points said, I understand the problem and I can explain it to other people clearly, or I can communicate it with other people clearly. Okay. Now here's the interesting part. You think that this is actually easy. Like sometimes it isn't for people who are not used to this. So for instance, it happens a lot. Let's say when I'm actually teaching, the students were simply getting stuck and looking at the screen like in the void. And then I say, what is your problem? And then the guy says I don't know how to solve the next, or I don't know how to solve this. And then I ask, I'm not saying, whether you can or not. I'm saying what exactly is the problem that you are trying to solve. If you can explain the problem, then you can solve it. Okay. If you cannot explain the problem, that means that you didn't understand the problem which you're trying to solve, and hence you will be staying in place and you will never move forward. So it's super important that you understand what is the current problem I'm trying to solve. Sometimes some people lose track, and if you lose track, just wake up, stay, be level-headed and stop for a second and think, what am I trying to solve? So I gave people in the class to model a solar system. Let's say we are making something dummy like No Man's Sky, for example. I would like to generate a solar system. How would I go about that? Let's identify the elements of the system. So I would like actually to include you in this discussion, because based on your outputs, I will actually like, you know, based on your output or based on your chat, I will actually start generating these classes like I did with the other people. So we can have this bidirectional. Hang on. Notepads, do I have it? Oh, I have it. Okay, so let's say right here, I would like to create a solar system. So what are the stuff which I need in order to model a solar system? Can somebody help me out here? We know that we have a star. We know we have planets. We know we have a moon for every planet. But what are the properties of each? So a star, what is the property of a star? No, forget about the implementation detail. Yeah, we need the properties, exactly. So we need a mass. But I mean, Peter, you're already going to the implementation. Let's not talk about the implementation. Let's talk about the exactly like what are the properties of things and what we need to solve, and then we'll go to the implementation. But good job on guessing. Type of the star, which is actually called the class of a star, which I'm going to keep it that way. So we have the mass, you have the class. We'll leave it there for now. Let's actually talk about the planet. What does the planet have? Water, okay. Mass and class has water, right? So it's going to be a Boolean of some sort, right? What else? Is habitable, or is inhabited. Inhabited. I don't know if I actually got the. I wouldn't say habitable zone is a Boolean, because a zone is like right now for every solar system is going to be different. If you have a blown over star owner, huh? That's interesting concept. Yeah. Still Earth. Okay, let's actually talk about the let's talk about the real ones, like away from the games a bit. We need names for everything. Yeah, exactly. Now you see things are actually starting to repeat here, isn't it? So we need a name, and this guy needs a name. Let's actually see here. So name, hang on. Has a population, I think is inhabited, can be like encapsulated behind this has a population, because a population would be like how many species you have, and then you keep out for population for each one of them. Actually, here's the fun part. The second group, the one right before you guys, actually two people have attempted to generate the names, literally like generate names live, and one of them actually made it, like randomly generate the name. Even of course it's just a bunch of mumbo jumbo, but it's a name generator, which I actually like that people just made the effort. But yeah, are we forgetting something for the planet? Like it needs array of moons, right? Which is an array or a collection of moons. It can be one, can be zero, it can be many. What else? Background? Like class? Oh, we will. We should actually, because if you look at this and this is repeatable somehow. At least I will forget about the class, because a class can be discussable, because you could have because a class should be an enum or a type. So a planet type is different from a class type of sorry, from a star type. So so I will leave this outside of the inheritance, but the inheritance should have these guys. Rotation and cycle revolution. So we have orbital period. We have circumference, exactly. So you have the radius, circumference, gravity, how much gravitational pull it has. Exactly, distance from the sun is going to be the order, right? I mean, we can go on and on. Okay, let's talk about the moon for a second here. What does the moon have? Name, mass, anything else? You can actually even argue is habitable or is inhabited, right? Because I mean, if you look at how we look at Enceladus and not Io, I think Io. I forgot what was the second one. And also there is another one near Saturn. I think we look at them as has potential for life, beside the gas giants, I mean. So one could argue if it is inhabited or not, like it does it have life on it or not. It can be the same. Moon can have cycles. Cycles is actually from the perspective of the observer on the so moon can have cycles. This is actually an observation from the planet, but if you actually look at it from the outside, it doesn't have these phases. It can be the same as planet. Well, it can be, but the problem is with moons are not actually, they are not even scientifically classified as a planet. So you're probably going to be in a false manner saying that the planet is a moon. So imagine that you are actually creating saying var moon equals to new planet. It's going to be super confusing. So I would actually prefer that the moon has its own type, even though it can repeat some stuff. We do surface area of all of them. Yeah, sure, why not? So you can have actually a surface area, and we can have surface area, and then you can have surface area here as well. You could even have, what was it? Circumference, orbital period. So you can actually go ahead and have fun with these guys as well. Okay. You should also have gravity, right? And we can go on and on. One of the things also that the solar system could have, which we actually forgot, we need the actual solar system, right? So the solar system itself has an array of planets, right? Planet array, planets, which is going to be an array. It could have a name as well, right? If you like to name things. What else do we have? For example, has asteroid belt. Because you never know. It might have it or it might not have it, depending on what kind of a solar system you're looking at. It might have multiple of them, but we will actually keep it as a Boolean for now, just to simplify things. Array of orbit paths. I mean, you can get that from the planet, an orbit path, right? But an orbit path will be, and depending on, it's going to have to be a math equation of some sort. It has a galaxy that it belongs to, which is also great. So you can have a galaxy, which you actually can have an array of solar systems. Now, whether you would like to have a bidirectional relationships or not, it's actually up to you. But this is basically it. So right now, what we could do, we can actually have an array of galaxies and just, like galaxy equal to new galaxy, and boom, you get a bunch of stars and and a bunch of solar system with stars and planet systems and stuff like that. So it's even though it can actually take some time for the computer to generate all that stuff as it should be, but it's fun project to work on. So this is actually the stuff which I've given to students. We ask ourselves, like, what the problem we are trying to solve here? Let's identify the components of the system which we are trying to build. And once you see the problem in front of you, like clear as a day, now you can actually start solving the problem. So right now, let's actually look at this and analyze it a little bit more. So for now, everything here has a name, apparently, and a mass. Even the galaxy has a mass, obviously, right? So a name and a mass is actually kind of repeating here. Even the gravitational pull of every object can be derived by its mass, but it doesn't matter. We will not actually sit down and try to derive the equations. So what we can do is, in order to solve this problem, I will add a new project, class library.NET framework, this one. And it's gonna be dummy No Man's Sky. Okay. And I will say here Control RR. And let's actually create I think Moon would be the easiest so far. Apparently didn't rename the class. So you see Moon here and the class here. So I'm going to call this Moon as well. Okay. Now it's 2 and 3. I will give you a small break, and then we will get back and we will continue working on the solar system. Please, if you have any questions, feel free to write them down, or any suggestions also. I will keep this on in case you would like to try this, to have this, to have a go at it by hand. And yeah, I'll just wait for your questions on the chat and I will answer them. See you after the break. So the break is 10 minutes. So it's going to be like, what, 2 and 15. All right. Hopefully you guys refreshed, and hopefully you guys maybe try to have a stab at the problem. I'll just simply like put this somewhere on the side. I'll maybe like, if you would like to just grab a screenshot so you can have this on the side beside the, the recording, or just as a reference, because I'm gonna put it on another monitor, and then yeah, so I'm just gonna take your screenshot now, and if you are done, I'll just simply like put it to the side, and now we can get to work. So one of the things which we have noticed so far is that the names have actually been, the name and the mass, practically speaking, is just being repeating everywhere. So probably we need to create one more class. We can call this a celestial object, or Nebiscutielo, right? And then what we can have is public string name and a public float mass, right? We can actually have this as an abstract class if we want to. During all the classes, I didn't create them as an abstract class, but we can actually give it as an abstract class for fun. And then right now, a moon inherits from this abstract class. So we have inherits from celestial object as well. Right now I can have an asteroid, which has a name and a mass as well, and it will work just fine. So what a moon has, the moon has a name, a mass, and Boolean is inhabited, right? And it's going to be public because I would like to be able to modify this thing. We have in there also the surface area. So public float, maybe surface area, as some suggested. Also, we're going to have a public float circumference. And then we're going to have a public float gravity. You could use double. I just don't need all the precision for such a small thing. So maybe circumference will require double or something like that, and surface area, but this is pretty much it. So this is like the things which can describe a moon that easily, right? And the orbital period. Actually, a celestial object can have public, let's say, float orbital period, because all of them, they orbit at a certain point in time, whether you're a moon or an asteroid or a star in a galaxy. Everyone has an orbital period. Even a rogue planet is orbiting within the galaxy. So yeah, it's pretty much the same thing. So this is the moon. I hope that I didn't forget anything else. Please remind me in the chat if I just missed something obvious. I will actually go ahead and create another class. I'm going to call this a planet. And right here is going to be also a public. And a planet has a name and a mass and a class. And a class has to be an actual class, like a type or an enum. But because we would like to make things a little bit easier, we could have it like a string planet class. Okay, and I'm gonna call it like planet class because, or maybe wait, this I think is not reserved keyword. Perfect. So we can have here. Somebody suggested that Boolean has water, so I'm just gonna have get and set. Is inhabited. Do we have it actually in celestial object or? Nope. So this is going to be public because a star cannot be inhabited, I think. So bool is inhabited, get and set. And what else do we have? Also, it has a circumference, so public float circumference. Hopefully I'm not actually making a mistake in the spelling here. It has a float gravity, or how much gravitational pull it has, and I think every celestial object has one, ever so tiny, but it could have one. So we could actually move it there and make the planet obviously inherit from that, so we don't forget this, right? I'm just simply moving things around, and I'm actually like merging stuff live. So please again, like correct me if I, like help me out if I actually lose something along the way. So the order, like what is the order of it from the sun? So are you the first? Are you the second? Are you the third? And so on and so forth, right? Order, gravity, circumference, orbital period. I think it's already in there. Yeah, you have, let me save this. Orbital period. Array of moons. So obviously I would have used the list, but for now, because we haven't covered generics and class, so I'm gonna have here moon, array of moons. So we're gonna use an array, a typical array. What else do we have? I think this is pretty much it for this specific type. Now let's actually go to the star. So a star obviously has inherits from a celestial object, and it has a class as well. So it's going to be public string class. I don't know honestly if asteroids has classes. Otherwise, I would have put it like as a class, but it also has the surface area and everything. So public float surface area, for example, or diameter, or whatever you would like to call it, circumference, and so on and so forth. But it has, yeah, I think this is it. Yeah, the class and the surface area, or let it be actually like a circumference for now. And we'll keep it that way. Actually, one of the students in one of the groups, he actually got the calculations of the circumference or the diameter based like he actually could calculate this stuff. So instead of like, you set the circumference by hand, based on, I don't know, radius cube times whatever the sine of something, you get actually the sine of diameter, or I really cannot remember the formula he used. He found on the internet, I guess. And then he just simply assigned it to that as a getter, and that's it. And you have an automatically calculated field or a property. So you might actually go ahead with that option as well. But for now, we are simplifying things. So this is what a star has. Now we need the solar system class. And again, if you think we need to add more, just feel free to let me know. So a solar system, right now it really depends on how you would like to look at it. So public class solar system, and then you can have a public. Right now you need to have, it can be a binary system, so array of stars, right? And then you can actually even query this. You can say bool is binary system. And then you can have something like this. For example, stars dot length larger than 1. So right now you have a solar system with a star larger than 1. If you try to query this with this being null or not uninitiated, we'll just simply put the question mark there. So we have, if it's actually null, then we'll not get the length, but if it is null, then we will actually we'll actually just get the length. However, it would be preferred that in your constructor you just simply say stars equals to new star array of 0 elements or something like that, just to be, just to be on the safe side. But we will not care about this for now. Also, a solar system has an array of planets. Okay, so this is like what you can actually do with a simple like method of, you know, generating a solar system. Just an array of stars. Maybe you have one or two. I don't know. I don't know if I have ever read about a system, a solar system with 3 stars. That would be interesting to see. But generally speaking, you can have a binary system or signal system. If you would like to, you can go ahead and add one more and call it a galaxy. And we can call it a day for this one. So we can say solar system, array of solar systems. Get and set. Now let's actually talk about like this part of how can we actually utilize this. So all of these guys are just simply a bunch of celestial objects. These guys are celestial object. This guy is a celestial object. So this inherits from there and everything. So let's actually use this somehow. If I actually go here, and again, I will do it slowly because it's super important that you get it right. So I will actually remove this guy. You know, we don't care about them right now. So you go to references, right click, add a reference. Okay. So you go to references, right click, add a reference. And then you select in the projects, because you could be having assembly. Actually, assembly is expanded. So you just simply expand projects. And then you choose the class library which you need. So this one, and I'm going to hit OK. Now it's actually being included here. Okay, so if I go into program, now I can easily say using dummy No Man's Sky right now on the top. If I didn't include this guy, it will actually give me an error. So right now I can actually, in the void main, I can generate a solar system. So I can say var solar, my solar fit solar system. There we go. Equals to new solar system, right? And right now you can say fit solar system dot, and then you have the stars, the planets is a binary system or not. So we can actually have dot planets equals to new planet array, and then we can actually have this object initialization syntax where we can add new planet. And right now here we can fill in everything, right? You can fill in the name, the orbital period, and stuff like that. Now here's the fun part. Let's actually go to the planet really quick, because I would love actually to be able to say like this: for int I equals 0 and I is less than fit solar system dot planets dot length. And I would like to say, and I would love to say this. Console.writeLine, like so, right? I would love to be able to do this. So if I would like to do this, you have to, sorry. Planets of I, like so. So for every planet, just please print me the stuff which I need to know about. So what you should do in this case is some people who got used to C++, we just stop this. They actually did the following. They actually have went to and said they made a method that does this, right? Which is fine. It's totally fine. However, what you could do, and actually both of the groups I've seen it. So what you could do is actually overwrite a string, which is better. So override toString, and then right here you can actually return what you would like to return. So for example, I would like to know. Let me just put interpolated strings here, and I would say, for example, this dot name, Actually, I will just simply write name equals to this guy. This, I could say, for example, order equals to this dot order. I'm just going to pick up some stuff which I'm going to fill randomly there, or not randomly, but rather in an interesting way, which I would like to hit, these certain points on. So I would like to know what is the name of that planet and which order, and for example, does it have water? So does it have water? And then, or for example, has water equals to, and right here you could actually have fun with this. So we say has water. Let's say has water equals true. I think you can say has water. Well, I can actually, I can write text, but this already can say true, false. So why not? Let me actually just print true, false directly there. Because why not? Okay. But you can actually say equals like, true, then you can write in your own text, false, you can write your other own text, but I'll actually leave it like so. It's okay. So, and one of the other students actually have made a really nice way of printing like the solar system itself. And he actually wanted to add colors, which was great. And I would like to show you how to alternate between the colors. So I would actually print the planets in one color and print the moons of the planets in another color. So I will show you how to do that in console. So right now I'm able to print the planets, but I need to generate them first. Now let's discuss the idea of the other students who actually generated the names. Now, if you would like to do this, I wouldn't say professionally, but if you would like to do name generation in general, I would advise you to look at something which is called Markov chain, and it's written like so. Let me just write it down. Comment Markov chain. Okay, and a Markov chain is a very famous statistical-based text generation algorithm. You can generate a text, you can generate words. Maybe sometimes it doesn't make sense, but it's actually kind of fun. Actually, I talked about it in multiple game dev conferences in the past, where we actually utilized it in games, not only to generate names, but to generate even levels and stuff like that. It's actually kind of fun tool. And it's also a fun programming exercise. The program itself is not that big. It's actually kind of, I don't know, like what, 20, 30 lines of codes, I think. You can actually implement it, and it's actually kind of fun. So I didn't implement it, to be honest, because it's a topic on its own. But I actually told people how it works, so I'm actually going to show you how it works really quick. So let's say if I write in solar system and I go to Wikipedia. So what Markov chain does in order to generate text, let's say I give it such a paragraph. Because it needs an input in order to give you an output. And the output will be based on the input. It's just mumbo jumbo thing. So for example, it will say, it will grab the first word. You can actually make it generate words or generate sentences. Let me talk about generating sentences because it's going to be easier. So I have an array or a dictionary of words. So I'm going to grab the first word. In C# you can grab a string and split it on spaces. So you're going to get array of words, literally. You're going to get the as an element, solar as an element, system as an element, is as an element, and so on and so forth. So you can get an array of words. And what it will do is say, okay, I will get the first word from the array, and then it will scan ahead, and it will say, what comes after the? So it has the solar and the system. And we'll create a dictionary or array of arrays. And it says like this. Under the word key, the, I will create an array that follows the word the, and I will put into it solar system. Okay. And the amount of words that you would like to look ahead, like how far you can go ahead, is called the order of the Markov chain. So right now, for example, this is the order of 2, as far as I remember. Order of 3 is meaning like grabbing 3 words and so on and so forth. As far as I remember. I don't know if it was, I can't remember if it was 0 based or 1 based, to be honest. I need to look into it again. But in any case, for example, it will grab the word the, it will say solar system, and then it will, next loop, it will grab the word solar. And then it will scan ahead, let's say 2 words. So it will say system is. It will add them into the array that belongs to the solar, array of arrays again. So, and then we'll pick up the next word, the system, and then it will scan ahead, right? Now, here's the interesting part. Once you reach the word the already has appeared here, okay? So what it will do, it will say, okay, the word the already exists in my array of arrays. What I will do is just simply add to the solar and the system items in the array under the word the, I will add gravitationally and bound, right? So right now you have the statistic, what happens after the. You have either this word, this word, this word, or this word. And if the word repeats, you will have double of them or triple of them in the array. That means that when you pick up randomly from them, there is a high chance that you can actually have that word appearing. So that's why it generates a very sound text. So if I actually grab, let's say, these 2 paragraphs, let me actually, or not here, let me actually Google really quick, Markov chain text generator, for example. And there we go. Let's actually grab this here. And let me grab this. And I will just put the text input, right? And the order is going to be 4, so it's just please get the, get 4 words ahead, and I'll hit go. And the output text is like this. I don't know what ROM is, but the gravitationally bound system is the gravitationally bound system planets, being composed of rock and Jupiter's moon Titan, are ice giants, planets and moons after Earth and Mars. Now, of course, this is actually it makes sentences that are sound, but they are not, but they don't make sense. However, if you actually add more and more text, it suddenly things started to become, becomes interestingly working as it should be. There are an unknown number of giant planets being composed of rock, metal. You see, it's kind of fun. Like this sentence is totally valid, for example, right? And this is the cool thing about Markov chain. It's actually quite fascinating. You can actually play with this and have fun with this, in many, many different ways. There are actually many variations of it. But again, I'm just talking about how would you like to generate words using a computer? I think this is the easiest or the lowest hanging fruit. But what we did was a student actually suggested, if I go into Google, there is a planet names generator. And I think, yeah, it was this one. So I actually copied a bunch of these guys. So for example, I have here, let's see, var lst or names, lookup names equals to new string array. Fine. I actually used lists because it was much easier, but fine, we can actually use arrays as well. And right now, obviously, I have to make it like so. So if you alt click and drag, you can create a column select. So I can do this, right? Yeah, and I need to do this here as well. Hang on, like so and like so. Okay, so alt and click, you can column select. You can actually even copy only this part. So if I copy this and there's notepads, if I actually paste it here, you'll see I just copied just only that column. So alt and click and drag. We push this aside. And let me generate more. for a good measure. I just need to find, where was that page though? Where did it go? Oh, there we go. So I'm just gonna click on that button again and have more of these guys, just for a good measure. And now obviously I have additional spaces there, which I don't mind right now. You could actually like go ahead and remove all the spaces. I mean, the options there are limitless, and comma, and we'll just move these guys right there. Yeah, I think it's fine for now. For now. I can even get more, but okay. So a planet. So how can we actually get a name for a planet? That's actually an interesting question, right? So what we could say is name equals to, and then right now randomly, we will pick up a name from there. Now what's going to be our index, right? Now you can actually use system.random. You have in C#, you have random. So let's say random index equals to new random. Okay. Oh, equals to new random. Okay. And this has to run once. You don't need to run it twice. And right here, random index. Oh, come on. Dot next. And then right there, there are actually multiple things. So one is actually giving you the non-negative integer, which is, I don't know what is going to be the non-negative random integer. So I think it goes to integer.max maybe. Here it's going to be the maximum value. Here I can provide the minimum and the maximum value. However, I think the maximum value is, I don't know, inclusive lower bound, but it doesn't say what is the, so if I actually say, for example, 0, comma, exclusive upper bound. So it will not grab the last element of the array. So I should say lookup names dot length. Oh, actually dot length, I think it will be okay because yeah, we'll see. We'll see. We will see. Okay, so let's see what else we wanted to have. I could actually have var random coin flip equals to new random. And why I'm doing this? Because I would love to say has water equals to random coin flip dot next. And then I can say, for example, minimum is 0, maximum is 2. If it is larger, then let's say if it is larger than 0, then it's actually gonna be true. Like so, there's gonna be true, else it's gonna be false. Right? This is actually a ternary operator, right? It's an if statement. I just simply said flip the coin. If the number which is returned from here is 0, then it's gonna be won't have water. However, sorry, if it is larger than 0, it's gonna have water. If it is wait, I made a mistake. If it's actually larger than 1, then it's gonna have water. If it is less than 1, then it will not have water, because that's why I actually made 2 here. Sorry. So there you go. And right now, what I could do is just hit the comma, copy that line, paste it several times. Because right now, this is actually being randomly generated for me. And whether it's having a water or not is also being randomly generated for me. As a matter of fact, what you can do also is you can assign the planet order based on its position in the array. But again, it's another story. We will not complicate it here. It's already complicated enough, I guess. So here's the fun part. We need to add moons in there, right? So I could so in order not to make the code unreadable, I'm gonna have here moons. Yeah, but you need an array of moons for each one of them. Fine, let it be so. I'm gonna actually like put a comma here. Moons equals to new moon. Actually, new moon array. And then right here, I'm gonna have new moon. And each moon should have a name. And the name, I'm gonna grab it right from there, because I'm gonna use the same naming scheme. So right there, name is gonna equal to that, right? And I'm just gonna leave it right there. I'm just gonna give it just a name, nothing more, okay? And I will just simply grab this, and each planet will have a single moon for now. Oh, of course, I need to have a comma, and this has to have a comma at the end, like so. Hang on, probably I actually just went way ahead of myself here. Like so. What am I missing? Oh, of course, it should have been right here. Sorry. Like so. Okay. And let me take this out here. Okay, good. So, and this will be like so. Okay, it actually figured it out for me. Perfect. So all of them are actually the same. Yeah, maybe I need just to add these spaces. And maybe I should remove these spaces indeed. I agree. Actually, I could even remove all these guys. And for the fun of it, just remove these guys. Okay. So right now I just simply generated the moons, a moon for every planet. So every planet has its own moon. Okay. Now, while I'm actually printing this, I would love actually to print the planet in red and then, or leave it in white, doesn't matter. However, give the moons in yellow. Okay. So I can actually say like this: for J in fit solar system dot planets of I dot moons, right, of, well, dot length. There we go. I will say, of course, I need to override to string this guy. So I have to say here, override to string. And here I'll just simply return the name, nothing more. So I'm just going to say name, moon name, this dot name. There we go. And now let's get back to program. And right here, I'm just going to have a console.color, foreground color, equals to console color, sorry, dot, we said yellow, did we? Okay, and right now we say console.writeLine, because this is a state machine. We should say this of J, right? Because we already overridden to string. And now, if I don't set this back to white, this will actually become all yellow. So I'm going to copy this, paste this here, and have this to white. And let's see if let's hope I didn't forget anything. Oh, there we go. So we have the planet name Chidora, has an order of 0, has water is false. Apparently none of them has water. Either I'm super unlucky or my randomness is not working. And this is moon name. Apparently I typed a weird character there, which has each one of them has a name, and it also has a yellow. It's already in yellow. If I actually forgotten this, and if I Control F5 this, the first line is in white and everybody else is yellow because this is like a state machine. You just simply set the state and everything will follow unless you say otherwise. That's why I had to Control KU this. And let's see, moon. Okay, so this one is bad. Let's see what's happening with the random coin flip though. Did I larger than or equal maybe? Maybe I forgot. Maybe it should have been equal. Maybe, I don't know. Let's see. Yeah, there you go. False, true, true, false, true. So some of them have water, some of them don't. And you can actually go ahead and play with this idea. Now, here's the interesting part, though. Right now, this is actually in the console. If you give this DLL to someone who uses C#, for example, in Unity or any game engine they have, they can actually, or graphics engine, they can utilize the same thing, but instead of printing up in console, they can render 3D objects. And this is why you use DLLs. You just simply send the DLL and say, hey, use this. And people will just simply like use it in order to generate stuff. So basically what the students did throughout the class was they have to write this all by hand. Some of them went creative and generated like a list. Another one has been creative and actually written the letters which he would like to combine in order to make words, which also was interesting to make, but yeah, he had a little bit more involved code. That's why I didn't use it here. I just used the simplified version of it. I think we haven't used random, or maybe I cannot remember honestly right now. But majority of them have actually went ahead and implemented all of these stuff. Probably right now you can actually go ahead and have fun with this by adding a solar system to a galaxy. So right now I can actually go ahead here and say that galaxy var fit galaxy equals to new galaxy, right? And then you can say fit galaxy dot solar systems equals to new solar system array. And then you can add right in there your fit solar system. And if you want to have a copy of it, just, you know, have one more. All right, I have two of them. So you have two solar systems within the galaxy. I will leave it as an exercise for you that you can print the whole galaxy if you want to. You can actually generate galaxies with names and stuff like that. I would advise you, like throughout the weekend, right now, that you just simply sit down, try to see if you can, like for real, like generate the words on your own instead of using a list of words. Try to see if you can generate a complete galaxy with all of its stuff. I will actually share the source code with you so you can have it as a reference, but make it in a way that, like if I say galaxy equals to new galaxy, you could randomly generate a full galaxy with like 1,000 of solar systems and everything just, you know, comes out of the code. This is a good exercise for you because right now you know how to control arrays, how to control inheritances, how to control object creation, null checks, right? Because, for example, you would like to query a solar system. You could say, give me that solar system, the first, for example, the third solar system in your galaxy, and then you say, how many habitable planets does it have? So you're going to make a for loop for every planet. Is it habitable, right? You can query a solar system tells you like how many moons that this solar system has in total, right? So right now you can actually sum up, like for example, if you look at our solar system, so Earth has a moon, Jupiter, Mars has 2 moons, Jupiter has, I don't know, 67. As far as I remember, I don't know, Saturn has like what, 70 something, I can't remember anymore. I don't know, like, and then you move on with other planets, and then when you sum them up, you get like 100 and something moons in total in our solar system, for example, right? So you will have to be able to structure your classes in a way that you can actually query the data and get some output that people can use. So I advise you actually to sit down and try that as a task. And if you get stuck, you just simply feel free to, send me an email or ping me over Microsoft Teams, and I will be happy to help. I will actually stop recording.